We've learned enough about scalar product of two vectors. The next type of product of vectors is called the vector product of two vectors. Vector product is also called the cross product of two vectors, and this is very important because unlike scalar product of vectors, the resultant of a vector product of vectors is also a vector quantity. So we come across many phenomena in physics where you have the product of two vectors resulting into another vector. So in those cases, the application of vector product of two vectors is useful. Let A bar, B bar be two non-zero and non-parallel vectors. Then the vector or cross product of these vectors is defined as the vector C bar, which is denoted as A bar cross B bar. The multiplication sign in between is read as cross, A bar cross B bar. And this can further be written as A bar cross B bar is equal to magnitude of A bar times magnitude of B bar times sine theta times n cap. What's n cap? N cap is a unit vector perpendicular to the plane of A bar and B bar. Why is n cap multiplied here on the right hand side? Because if you would notice, everything else is just a scalar quantity. The magnitude of A bar is a constant or a scalar quantity. Magnitude of B bar also. Sine of the angle theta between them is also a scalar quantity. So therefore, since we mentioned that vector product of two vectors is also a vector quantity, the right hand side has to have a vector quantity to make it a vector quantity. So therefore, n cap is multiplied by all those scalars to make the right hand side a vector quantity, just like the left hand side. So theta is the angle between the vectors A bar and B bar. As much as possible, the angle theta is considered to be the acute angle between the vectors A bar and B bar. So n cap is a unit vector perpendicular to the plane of A bar and B bar. So again, any two vectors of course are coplanar. That is, they can lie on the same plane or they can be lying on planes which are parallel to each other, which can be considered as a single plane. So therefore, the cross product or the vector product of A bar and B bar can be considered to be in a direction which is perpendicular to the plane containing A bar and B bar. For example, if the vectors A bar and B bar lie on the surface of this table, some going this way and another going this way, then their resultant will be in a direction which is perpendicular to the plane of this table, going either upwards or downwards like this. So therefore, A bar and B bar can be imagined to constitute a right hand system when we take their vector product. For example, if we take the three fingers of our right hand and we take the index finger as one of the vectors of the cross product and the middle finger as the second vector, then the resultant could either be pointing in the direction of the thumb in the same direction or 180 degrees opposite to it, so that if the middle finger and the index finger are considered to lie in the same plane, then their cross product will lie in a plane which is perpendicular to the two vectors.